All right, here we go, math students. We're going to do some word problems involving inequalities today. So you know the drill. You can pause this video at any time. Make sure you ask your teacher if you've got any questions. So word problems with inequalities. So we've got some symbols here, a less than, greater than. Less than or equal to, it looks like a less than symbol when it's underlined, and then a greater than symbol that's also underlined. So that's a mix between a less than, and it could also be equal to that number, and then the greater than, and it also could be equal to whatever number is given. So write these down, and then write the translations for each one. So it's changing it from words, like in a story problem, into math symbols. So take some time to pause the video and write these explanations down. Okay, there's actually 4 examples of notes today. These are the first 2. So if you're trying to space your foldable out, you can see how much space you're going to need for each one. Again, pause the video, copy these down, and then I'll go through and explain. So in our first example A, we've got a situation where you must weigh more than 100 pounds to go on a certain ride. This is kind of like at a fair or something like that. For safety reasons, you have to weigh more than 100 pounds. They don't want you flying off the ride. So your weight, we're going to say maybe that's like a W, okay, has to be more than, so that means we're going to use our greater than symbol, and 100. So your weight has to be greater than 100. And that's all we're looking for, is just writing that inequality to represent that situation. Okay, so I picked a variable, and then I have the number 100, and then I also have that greater than symbol. On the bottom, the members of a dive team must be under 15 years of age. So their age is the part that we're looking at for the variable here. So age, we can just say letter A for age, must be under, okay, there's our under, 15 years. So 15 is going to be our number. So under would be a less than, and 15. Now if you want, you can also write this backwards. Just make sure if you're writing it backwards that you're also flipping and reversing that inequality. So you could say 15 is the greatest age, and their age has to be less than 15. Always read these inequalities from the variable side first. So this would read A, the age, is less than, okay, less than, it points at the smaller one, 15. So 15 is greater than the age. So you can write this either way, as long as you have that alligator eating the bigger number. So in this case, the alligator is eating the 15. Example B, you must be 18 years of age or older to vote. This is one of those examples where you can also be 18 and still vote. So we're talking about age again, so I'm going to use the variable A. So your age in order to vote, according to this problem and real life, has to be greater than or equal to 18. So that means you can also be 18, and that's where this underline part comes. You can be equal to 18 and still vote, and you can be over 18 or older than 18. So you can be greater than or equal to, so we use that underline in this case to represent all of those different ages. So there's an infinite number of numbers or ages that would make this statement true. You know, you could be 100 and you could vote. You could not be 17, because 17 is not greater than or equal to 18. Okay? In the last one there, we have a water tank holds at most 18 gallons of liquid. So we've got our tank that we're looking at. Maybe in this case, since we're talking about gallons, maybe we're going to talk about, you know, G, okay, can be our variable. And the tank itself can hold at most 18 gallons. So we're going to need that number 18, okay? So if you, you could look at the chart for one. So here we've got our at most in the chart that you just wrote down. But also think about this tank for a situation. The tank has to be, you know, if you've got a tank of water, a tank of liquid, okay, and it holds 18 gallons, the highest that it can be is 18. All the amounts below that would work in this situation, and it could also equal 18 gallons, okay? So it's okay to use some common sense on some of these problems too. You know, think of a number like 20 maybe. If you put 20 gallons of water in this tank, it's going to overflow. So this gallons, this G that you're representing, has to be a number smaller than the 18, or it could equal 18. You could also hold 18 gallons of liquid in that tank, okay? Our next set, two more examples. Here we've got some translating each sentence or situation into an algebraic inequality. That's just what we were doing on the last one. And then we're also going to be solving these. So these have a little bit more, one more step to the inequality. Okay, so take a minute to copy these down and then I'll go through them. So our first one, William and Kate can spend no more than $150 on toys. If Kate spent $80 already, how much can William spend? So we've got a combined total for these two. So combined total would mean that we're adding those two amounts together. So what we're going to do is we've got our two variables here. We've got our William plus our Kate, and they can spend no more than $150. So that means their amount that they spend has to be less than or equal to $150. Okay? Well, we already know that Kate spent $80. Okay, so what I'm going to do is I'm going to take Kate's amount, take out that K, and put an 80 in its place. So we've got William plus 80 still has to be less than 150. So here we've got an inequality addition sentence that we need to solve. Okay, so there's the first step, is to write the inequality. Okay, and now we need to solve it. So remember, when we're solving these, we're going to solve them just like an equation. So W plus 80 is less than or equal to 150. So just like we were solving these previously, we're going to draw a line down that equals, or that inequality. I'm going to do the inverse operation here. So I'm going to take 80 away from both sides. So we've got a solution here of W is less than or equal to 150 minus 80 is 70. So in word format, this would mean that William's amount that he can spend has to be less than or equal to $70. Okay? In our second story problem, we have Howard's height is at most 3 times larger than the dog's height. If Howard is 68 inches, what can be the dog's height? Okay, so we've got our inequality here. We have Howard's height. So for Howard's height, I'm going to say maybe that's H. Okay, it's at most, so there's another keyword, 3 times, so that's going to be our multiplication, larger than the dog's height, and I'm going to just use a D for the dog's height for now. So we've got Howard's height, okay, is at most, okay, so the most that it can be, that means it has to be under 3 times the dog's height. Okay, it has to be under the dog's, at most 3 times larger than the dog's height. Okay, so if Howard is 68 inches, 68 for Howard has to be less than or equal to 3 times the dog's height. Okay, so we've got this second part taken care of. If Howard is 68, what can the dog's height be? So now we need to solve it. So here's our inequality. And again, when you have this 3 times D, you can either write it with that dot for multiplication, or you can also write it with no symbol at all, or maybe parentheses or something, but no X's. Remember, X's are variables now. So when we solve this, we're still going to solve it like regular, 68 less than or equal to 3D. You know, draw that line down that inequality. And in this case, we're going to divide both sides of our inequality by 3. So we get a D on the right. Notice the sign or the symbol, the inequality, stays the same. This is not a flip the switch problem because we're dividing by 3. Okay, it's a positive coefficient here, so the symbol is going to stay the same. 68 divided by 3, it's not an even number. Okay, so it goes in there 22 goes in there twice. And we still have a remainder 2. So 22 and 2/3. So that means the dog's height has to be under or equal to 22 and 2/3 inches. Okay, so there we've got some story problems that relate to those math inequalities and doing a little bit of solving with it as well. Again, ask your teacher if you've got any questions. Thanks.